Hi guys, welcome back to Codera. Today's topic is frog jump. A frog wants to climb a staircase with n steps given an integer array heights where heights I contains the height of the ith step. To jump from the ith step to j step, the frog requires abs height I minus height j. That means if a frog jump from 0th index to the first index, the absolute difference of the 2 minus 1 is the energy required by the frog to jump from one step to another step. Where the abs denotes the absolute difference, the frog can jump from any step either 1 or 2 steps, provided it exists. Return the minimum amount of energy required by the frog to go from the 0th step to the n minus 1 step. So, let me explain. Okay, let's get into the solution of the frog jump. The frog has to jump from one step to another step with the energy of the absolute difference between the both heights of the step. Now, we have to find the minimum amount of energy required by the frog to go from the 0th step to the n minus 1th step. Now, here you can see that 10, 20, 30, 10 are the height of the steps. Now, the frog will jump from the 10 to 20 with a energy of 20 minus 10 which is 10. Now, the 20th height of the step, it jumps to the 30th height of the step with an energy difference of 10. From there, it jumps to the n minus 1 step with a height difference of 20. And it overall, it takes 40. And another way, if the frog jumps from the first index to the next index with a difference of 10, and from the second index, it jumps to the n minus 1 index with a 2-step of difference of 10, and it takes 20. It is the minimum amount of energy. And it has another option also. It can jump from the first index to the second index, and from the second index to the third index, where it takes 40. And from the overall ways, the minimum amount of energy is 20. So you can even think that we can even do the greedy, but the greedy fails here. I'll explain how. Listen. If you see the index 30, 10, 60, 10, 60, 50, if you come in case of greedy, the greedy checks whether it has to jump for the lowest or the highest. As per our condition, we have to jump over a minimum amount of energy. So the greedy checks which is the minimum energy. So from 30 to 10, it takes 20 if it takes one step, and if 30 to 60, it takes 2 steps and takes 30. So the greedy tries to jump from 30 to 10, which takes 20. And now from the second index, it is the first index 0, 1, 2, 3, 4, 5. From the first index, now it goes to the next index and checks whether it takes single step or double step. If it takes a double step, from 10 to 10, the difference is 0. So the greedy will occupy this way. And from the third index, it goes to the last index with a difference of 40. And if it goes to next index, it takes 50. So the greedy will choose the 40 path. So the 40 plus 20 which gives 60. As greedy follows this. But if we follow the DP, we have another option also. In this DP case, from 0, 1, 2, 3, 4, 5, the frog jump from 30 to 60, it takes 30 as energy, and from 60 to 60, the energy is 0, and from 60 to 50, it takes 10, and it's 40. Previously, it has taken 60. C, which is the minimum energy, 40. So the greedy fails here. This is due to uniformity. Now, in this first, we have to try the recursion and try all possible ways. Previously in the video, I have said you have to remember the 3 steps to do DP questions. That is, first you have to identify the index and do all stuffs on that index and take the minimum on all the index stuff. Why have we taken this minimum? Because the question asks what is the minimum amount of energy required by the frog to go from a 0th step to n minus 1 step. Okay. Now let's get into the code. F of index where it is the n minus 1 step, the last step. If let's see in case of index, let's assume the frog is at the 0th index. So there is no way the frog can jump more. So we have to return 0. There is no way the frog can move forward or backward. Since because we are coming from the top to bottom, 0 is the last index, the frog cannot move anywhere. So we have to return 0. So we have taken if case where index is equal to 0, return 0. And now we have to see the where the frog can step one single step or takes a two single step. Let's take left is equal to f of index minus 1 where the frog takes single step, plus we have to find the difference between the both heights in order to get the amount of energy it takes to jump from one step to another step. Here absolute difference between the index of the frog where it has stayed previously and to the index it going to jump next. A of index minus 1, index array of index minus array of index minus 1. And if it comes to the second two steps, f of index minus 2 plus absolute difference of array of index minus array of index minus 2. Here you have to think if the frog is at the first step, it cannot move to the index minus 2 place because 1 minus 2 it takes minus 1. So in that case, for this particular two steps, we have to put an if case where the index has to be greater than 1 so that the frog doesn't go into negative value. And we have to return, as per our question, we have to return which is the minimum. So return the minimum left and right among both the cases, and I'll explain how it works. Here 30, 20, 10, 60, 10, 60, 50. These are the heights of an array given. So n is equal to 6. So first index we have taken n minus 1. So we will start from the 50, and for the as per the left case, left f of index minus 1, f of index minus 2, we just subtract the index 5 minus 1 and 5 minus 2, which is 4 and 3. And from let's take only the function 4 where it is, let's find the left and right. 4 minus 1, 4 minus 2, and for this function 3 minus 1, 3 minus 2, and for this function 2 minus 1, 2 minus 2, 0, and for this function 1 minus 1 and 1 minus 2 is not possible. As per our index in the code, as per the index in our code, if the index is equal to 0, we have to return 0. So here if you see, the index is 0, it will return 0, and then after the function f of 1, left is equal to f of 0 plus the array difference. Array difference is, you see, from 1 to 0 the difference is 20, and when it comes to right there is no right, so let's assume it max, and the minimum of this both is left. So f of 1 is 20, and if you go to f of 2 function, the difference between f of 2 and f of 1 difference is 0, 1, 2, 3, 4, 5. F of 2 and f of 1 is 50 as per the f of 2 function. Left is equal to f of 1 plus the difference is 30, and for right f of 1 plus the difference between 60 minus 1 is 50, and from second index to the last index, 0 index, this 30, and we know the f of 1 value is 20, so f of 1 is equal to 20, so it's equal to 70. Among 70 and 30, it is f of 0, and f of 0 is 0, so 30, among 70 and 30, the lowest is 30, so f of 2 value is 30. And now for the f of 3 function, the difference between f of 3 and f of 2 is 50, and 50 plus, and f of 2 function value is 30, so left is equal to 80, and for the right, f of 3 and f of 1, the difference is 0, plus the f of 1 value, it is already in 20, so it is an overlapping situation, so its value is 20. Here, will you once again go for the f of 1 function and find the f of 1 value? This is basically an overlapping problem. You will go to the DP array and will find the f of 1 value, and I will show you how. And in the same way, you will get the f of 4 to f of 3. The difference is f of 4 to f of 3 is 50, and 50 plus f of 3 value, which is, so therefore we will find out 20, so 20 is the value of f of 3. And now for f of 4, the value is 20 plus 50, 70, and then for f of 2, f of 4 to f of 2, the difference is 0, plus f of 2 value we can find from the DP table, it is 30, so 30. Now the minimum of the both is 30, so f of 4 value is 30. Since we know the f of 3 value is also 30, so the final answer is, we get this, f of 5 is equal to 30. So since I haven't calculated the difference, from 50 to 60, the difference is 10, plus 10, it is 40, and from the 5th index to 3rd index, the difference is 40, so 30 plus 40, 70, among 70 and 40, 40 is the minimum, so 40 goes here, for 5 is equal to 40. So now let's understand the code. Here there is an overlapping problem occurs where the function has to be solved and stored in a DP. For that we use the memoization technique. For the memoization technique, there's no need of more thought, just we have to create a vector in DP of size n plus 1 and minus 1. You guys will be wondering that why I have taken this n plus 1, not n. It's not necessary for this particular case because it is 0 index based question. In the previous Fibonacci type, we have n minus 2 where we have the index goes to the last index 0 and minus 1. So in that case we have used it. For that in case we have used n plus 1. If you use n also, nothing goes wrong with the complexity of the code. So now if you see the code, we have to just store the DP of index is equal to minimum, and if DP of index is not equal to minus 1, for the overlapping case return the DP of index. This return of DP index gives the previously stored function value, and it is easy to identify now. Now the complexity is O of n, where we all perform the functions 1, 2, 3, 4, 5 for all that, and space complexity O of n plus O of n, where O of n is the array and O of n is the recursive stack space. You have to remember this O of n, recursion stack trace. In order to avoid this space complexity, we use the tabulation method where we don't need any recursion stack space over there. Now I will explain how. Tabulation is basically it's a bottom-up approach. This is different from top-down approach of memoization, where in memoization we go from the n-1 to 0 index, but here in tabulation we go from the 0 index to n-1 index. I'll show how. Firstly, you have to create an array dp. As I said, you can create n+1 or n, no problem for this case. And as per the previously our code, in the index case, index is equal to 0, return 0. So our dp of 0 has to be 0. And now the frog will jump from first index to the last index. So our for loop has to be from the first index to the n-1 last index. And now after the previously code, just copy paste what you have done for the left and right into the tabulation code. Left, what you have written f of index minus 1 plus absolute difference of array of index minus 1. Just copy this particular part and paste in the tabulation method. And I have copied that and paste in this, and as usual dp of index is equal to minimum of f of first minus second one, and you will get the tabulation method in this, and we have to give the output of dp of n-1 where it stores the final value. And now the time complexity O of n and space complexity O of n, where the stack space recursion stack space has been detected now. Now in here, if you see, if there is an index minus 1 and index minus 2, there is definitely a space optimization technique to be applied. See how. If you see, as per previously I said in the first video of this DP series, where you have even remembered that the dots that I have described will represent the previous one, previous two, current I, all the same case. If the dp of I is in the current place, dp of I minus 1 in the previous place, and the dp of I minus 2 in the previous place, and the next dp of I has its previous on the previous dp of I, and the next dp of I of the previous I becomes the I minus 2 of the next dp of I. In the same case, here the current I, previous 2 I, in the same case we can even space optimize our solution by changing our values further. Here, if you see, we change the index minus 2, and let's change this dp of index minus 2 index as current I, and index minus 1 as previous 1 and previous 2, and whereas the previous 2 becomes previous 1 and the previous 1 becomes the current I. In this case also we get a space optimization of O of 1 space complexity. The interviewer asks for a O of 1 complexity, you can use this case. It's a very nice method. So hope you guys understood this solution. Thank you. Please subscribe and click the bell icon.